Okay, so the next video in this unit talks about how to do function operations and how to do function compositions. So function operations are just our four basic operations of addition, subtraction, multiplication, and division. So what we find is that we can add and subtract, multiply and divide functions just like we can with numbers. So if you're given two separate functions such as 5x and x plus 2, we can do things like add them together. So when I add things together like that, all I'm doing is combining like terms. So notice that 5x plus x gives me 6x, and then I've got this 2 tacked on the end because I don't have anything else to combine it with. The next one about subtraction, all I'm doing is subtracting 5x and the other function, keeping in mind that that negative affects the x and the 2. 5x minus x gives me 4x, and then minus a 2 gives me minus 2. We can also multiply the functions. So if I multiply 5x and x plus 2, this just becomes a distributive property problem. So distributing 5x and x is 5x squared, 5x and 2 is 10x. The last one is division. So when I divide the two functions, I have a 5x on top and an x plus 2 on the bottom. Now, there is no way to simplify this. If we could simplify, then we would. In this particular case, there is no way to simplify this, so that would just remain that as the answer. Now, what we can do for each one of these is determine what its domain is. So what kind of x values can I put into that operation? So what you're looking at when you figure that out is what are the domains of the original functions that I used. So here, if you think about it, that's a linear function, which is a kind of polynomial. Anytime we look at the domain of any kind of polynomial, we say that our domain is all real numbers. Same thing is true here. That is also a linear function, so it has a domain of all real numbers. When I add the functions together, we get this result. And looking at that result, it's also a linear function, so it would have a domain of all real numbers. Same thing happens with subtraction, looking at the originals and then the end result. The end result is a linear function, which means that it has a domain of all real numbers. So what does that mean? It means that I can take any value I want and I can put it in for x, and it's going to give me something as the y value. Next one down was the multiplication. Again, originals were all real numbers, and then we get a quadratic polynomial after we multiply. Quadratics, since they're a kind of polynomial, are also a domain of all real numbers. The last one is the tricky one, the division. So the original functions didn't have any problems. Again, they're both linear. This, however, has a problem. Since I have a denominator here, there are values that I can plug in that's going to give me a 0 in the denominator, which is not allowed in algebra. So what we need to do is figure out what value would make that denominator 0, and we're going to take that value out of our domain. So that value there is found by just setting the denominator equal to 0 and finding the value of x that makes that true, which in this case is -2. So we would say that our domain is everything except -2, because that's the value that makes the denominator 0. So my all real numbers, x can't equal -2. That would be our domain for this division operation. So what we're going to do is look at some different kinds of functions and how we do their operations and find their domains. So the first one we're going to do, the first problem here is just addition and subtraction. So notice that these two functions, one of them is 4x to the 1/2, the other is -9x to the 1/2. They are both actually square root functions. 4x to the 1/2 is the same thing as 4 square root of x. 9x to the 1/2 is the same thing as -9 square root of x. Okay, keeping in mind that in the first unit we talked about how the 1/2 power was the same thing as a square root. We talked about how to add radicals together in that first unit. All we have to do is add the numbers in the front together, which would give me -5. And then since these both have a square root of x, we would have negative 5 square root of x. The exact same process takes place for the subtraction operation. So 4 square root of x minus negative 9 square root of x. Since the radicals are the same, all I have to do is combine the numbers in the front. 4 minus negative 9 would become 13 square root of x. Subtracting a negative is the same thing as adding a positive. And the last thing that they want you to do here is find the domains of each. So what x values could I put into each one of these to get a y value out? So each one of these has an issue, the fact that they both have a square root. We know that the underneath portion of a square root has to be positive. It can't be negative underneath, meaning that if I wanted to put a value in there for x, I could put numbers like 1, 2, 10, 100, 150, 1 million. As long as they were positive values, they work. But I can also put in 0 because it's okay to take the square root of 0. So that means that I can put any number in there I want as long as it's from 0 and bigger. So how would I show that? As a domain, I'm going to write interval notation from 0 to infinity. The 0 would be included and the infinity is not. Now what we figure out is that the addition and subtraction domains actually end up being the exact same because they both have the exact same issue. They both have square roots in them, which means both of them have to lose out on using any negative numbers. On the bottom of the page is where we get into the multiplication and division operations. So notice that we've changed the functions. Now we're using a linear function, and this one is a rooted function. Right now it's written in exponent form, and we'll talk about why in a second. So the first thing that we're being asked to do is multiply the functions together. So I'm going to take those two functions, 6x and x to the 3/4, and we're going to multiply them together. Now here is why we had to learn exponent properties in the first unit, because we have to add those exponents together when we're multiplying like bases. So that's an exponent of 1. So if I add up 1 and 3/4, we have to write our exponents as improper fractions. They cannot be written as a mixed number. So I need to change this 1 into having a denominator of 4. That would be 4/4. Now that they have the same denominator, I can add them together and I get a fraction of 7/4. So when I multiply these two functions together, we're going to get 6x to the 7/4 power. That's going to be the answer for your multiplication operation. In the next one, we're being asked to divide the functions. So we're going to take the same two functions, keeping in mind which one goes on top and which one goes on bottom. The one on top is the f function, which is 6x, and the bottom one is the x to the 3/4. Okay, so after we've written them as a fraction, again, if it's able to be simplified, we have to simplify. Now I've got x's top and bottom. Using our exponent properties we learned in the first unit, you have to subtract the powers. So if I take 1 and subtract 3/4, again, if you want the technical reason, we're going to change into 4/4, which would give me an exponent of 1/4. So my final answer here, when simplified, would give me 6x to the 1/4 power. The last part of these problems is to figure out the domain. So let's figure that out. So for the multiplication operation, we got an end answer of 6x to the 7/4. So what we want to do is look at our two original functions. Did these have any restrictions? 6x is a linear polynomial that has no restrictions, all real numbers. This appears like it's going to have no restrictions because it looks kind of like a polynomial, but it actually is not. anytime we have a fractional exponent like that, we can rewrite the expression as a radical. So this would be the fourth root of x cubed. Since it is an even kind of root, an even root, that means I can't put any negatives underneath that radical. Can't take the even root of a negative number, which means that all of my negatives are now out. 0 is still in play, and so are my positives. So we come over to the operation now and see, does this add anything on that we can't use? Well, if I write this in radical form, it would look like this. 6 fourth root of x to the 7th. So again, this is going to have the same issue with not using negatives. I have an even root, which means I can take the even root of 0. I can also take the even root of anything positive. I can't take the even root of anything negative. So that means that for my domain, we can use anything from 0 and bigger, but we can't use anything negative. In letter B, its domain, again, the first thing you do is check your original functions. What things do I have to throw out because of these two? 6x doesn't require me to throw out anything. X to the 3/4, since it's an even root, that means I have to throw out anything negative. So when I come over to my operation, I already know the only numbers in play are my positive numbers and 0. Now this one appears that it's going to come out the exact same domain as the original, but notice that when we first plugged the numbers in, or plugged the functions in, I had an x in the denominator. Since I have an x in the denominator in the first step, I have to take out an x value of 0 also. So not only are all of my negatives out, but now 0 is out of play also because I have this x in the denominator before I simplified. So when I write my domain, we're still going to do from 0 to infinity, but the change is I'm no longer including 0. So yes, bracket and parenthesis have a really, really big difference between the two. 0 works for the multiplication operation. 0 does not work for the division operation. So that's kind of a general overview of adding, subtracting, multiplying, and dividing functions. The next part of the video is going to cover compositions. So let's talk first about what a composition is. A composition is just an evaluation. You're going to see things that look like this, g of f of x. So notice that if I start off with just g of x, if I take that x out and I put f in its place, that means that in the g function, I'm going to take out any x's that I see, and I'm going to put the f of x function in its place. I can also do it the other way around and do f of g of x. So anywhere I see an x in the f function, I'm going to take it out and put g of x in its place. We're also going to talk about how to find the domains of these different compositions, but we will do that after we've actually done a composition. So what we're going to do is skip the first problem here, and we're going to go to the second one. And the second one gives us two functions, and it asks us to do a few separate compositions. So let's first talk about this first one, f of g. So in letter A, f of g of x. F of x, notice, is this expression for x to the negative first. So that means that I'm going to take the x out of that function, and I'm going to put g in its place. G is 5x minus 2. So where that x was, all I'm going to do is replace that space with x minus, or 5x minus 2. My job then is to simplify this if it's possible. In this case it is. No, you cannot distribute the 4. No, you cannot distribute the negative 1 power. However, you can fix this negative first power by making it positive and moving this parenthesis to the denominator of a fraction. So 4 on the top, 5x minus 2 on the bottom. That would be the answer for your composition. So what do I do then if I want to figure out its domain? What values would work in here? What you check is the function I plugged in and the function that you get as the answer. So the function I plugged in, 5x minus 2, is a linear function. That means that the function I plugged in doesn't get rid of any values that wouldn't work. The function I got as my answer, however, does have an issue. Notice how it became a fraction. Since it became a fraction, whatever makes this denominator equal to 0, that value has to come out of my domain. So if I set that denominator equal to 0 and solve, you'd add 2 and divide by 5, which gives you 2/5. So when I'm talking about the domain of this composition, x can be anything except 2/5. If we go about letter B wants us to do g of f. So if I just switch the order, does it make a big difference? The answer is going to be yes. So in my g function, I'm going to take out my x. And in its place, I'm going to put the f function. In this case, 4x to the negative first. So my job is to simplify this if it's possible. And the answer is yes, you can simplify it. See how this -1 is only attached to the x. So that term is going to move to the denominator of the fraction. So we're going to have a fraction with an x in the denominator. And then 4 times 5 gives me a total of 20. That -1 is not affecting the 4. That -1 is only attached to the x. That's why I'm able to just multiply 4 and 5 to get 20. Now, could you put these together into one fraction? Yes. We're not going to because it's not going to do anything to help us simplify. It just is the way it is. So the last thing you'd need to figure out is what issues am I going to have with my domain? So you check what you plugged in and what you got as the answer. So let's talk about what I plugged in. 4x to the negative first. If I wanted to make that a positive power, then that would drop to the denominator. So I'd have 4 over x. So you have to ask yourself, is there a value that's going to make this denominator equal to 0? And the answer is yes. I can't use 0. Any negative number will work. Any positive number will work. 0 will not work. When I come down to my composition down here, does this add any more numbers on that don't work? The answer is no. We still have that 0 doesn't work. So they're in agreement. 0 doesn't work. Everything else will. I can plug in any positive value I want. I can plug in any negative value I want. And I'm going to get a y value as the answer. So we would say that our domain was everything except an x value of 0. So what I've got on the next page is a couple of more examples with some different looking functions. So let's do a couple more examples of these. So in the next one, let's just do one of these. Let's do f of g. So if we're doing f of g, that means we're taking the x's out of f. So 4 parentheses squared minus parentheses. And in each place, we're putting the g function, 2x squared and 2x squared. So how do I simplify this? If I square 2x squared, we get 4x to the fourth. If I multiply 4x to the fourth by 4, we get 16x to the fourth. And that's my final answer. No, you don't need to factor it. No, you don't need to set it equal to 0 and solve for x, because this problem doesn't ask you to do any of those things. You only have to do those things when the problem says to. So the last thing we would determine is what's the domain. So let's talk about the function you plugged in. I plugged in 2x squared. 2x squared is a polynomial, which means that I can use any value I want because polynomials have domains of all real numbers. So the only thing that would add a restriction is if the end result here after your composition had any issues. And in this case, it does not. This is also a polynomial, which means that I have no restrictions on the x values I can use. We can literally use any value we want, and it's going to give us a y value as the answer. Moving down, let's talk about a little bit more complicated. So a little bit more complicated. The first thing I want to do, I want you to fix this for me. I want you to scratch out this squared. That would pull in a concept that we haven't really had a chance to talk about yet. So let's just make that 9 minus x instead of 9 minus x squared. So if we're doing, again, f of g, we're going to take out the x of the f function, and we're going to plug in its place the g function. Now keep in mind that we scratched out that little squared, so it's just 9 minus x. So we're supposed to simplify if we can. So let's simplify. Squaring a square root cancels them out. So you have 9 minus x minus 9. And then if you subtract the 9's, you end up with just negative x. So I'm supposed to figure out whether or not there are any restrictions. So let's talk about the things you have to check. You have to check the function you plugged in, which in this case is this one, and then the result that you get out. Now, looking at the result you get out, negative x is a linear polynomial, meaning that you could use anything you want. So the end result doesn't have any restrictions. However, what I plugged in is a square root function. And we talked about the beginning of this current unit that square root functions have issues. I can't take the square root of a negative value, meaning that what's underneath here has to come out 0 or bigger. So if I plug a number in for x, say I plug in 5, 9 minus 5 is 4, I can take the square root of 4. If I plug in a value like 0, 9 minus 0 is 9, so I can take the square root of 9. If I plug in a number like 12, 9 minus 12 is negative 3. 12 would be a problem. So what I want to do is take the underneath portion of this, and I want to figure out for what values of x is it greater than or equal to 0. So all we're going to do to solve that is subtract 9, and then divide by negative 1. Notice that when you divide by negative 1, the sign flips, and this is actually your domain. X can be anything as long as it's 9 or smaller. So I can use 9 in here. I can use 8, 7, 6, 5, negative 2, negative 3, negative 4, all the way down. Because as long as the number that I plug in makes the underneath portion of the root a positive number, then I don't have an issue. If I plug a number like 10 in, or 11, or 12, or 20, or 100, I'm going to have a negative underneath the root, which I can't evaluate. So we would say that our domain is anything that's 9 or smaller. In interval notation, we would go negative infinity to positive 9. Notice that I wrote these from smallest to largest. Please make sure that you're writing your intervals from smallest to largest. And then we are including the 9. It's okay to do 9 minus 9 and get 0 because the square root of 0 is just 0. 0 is not okay in the denominator of a fraction. It is okay underneath a root. Make note of any issues that you have or questions, and we can talk about those issues in class tomorrow.